Hi, my name is Sigrid. Yeah, I really want to get into the first city, but I regret that there's no live stream will be happen because of the lack of the Wi-Fi connectivity. Yeah, and I visited first city network school thanks to the invitation of Daniel Kang last week. I stayed one night and it was really amazing. I was in the orientation day of the March cohort, and yeah, I really love the vibe. So I'm considering to stay every weekend on April, because I think there's massive possibilities are there in network school. Yeah, I'm really follower. I was in the crypto some years ago and I ran a Ethereum validator at the time. And I really like the vibe there. So still I believe there's lots of things into crypto and there will be such a huge things if we converge crypto and AI. So yeah, I think I just want to stay for on the every weekend on April. So please say hi if you are there. Yeah. So okay. So let me just intro myself. My name is Sigrid, and I'm here in the University of British Columbia. And yeah, I have worked as an ultra think engineer. What's an ultra think engineer? It's all mean trying to use all of the harness possibilities from your models. Like what I'm just trying to say is model has already reached agent intelligence, I believe. And the most important thing is how to extract those intelligence, yeah, from the model. That's what I believe. So the most important thing, what I try to do is to make sure that we make a best workflow, best harness from each model, and to make sure that we can leverage those ones. And what humans should do is to try to look at the context that AI can miss, because we do have conversation with other human beings in a very high context manner. And when it comes for AI, they are really easy to miss those contexts. So the most important thing for human is to inject appropriate information at the runtime. So I think the most important thing for it is to how do we engineer itself. So it is directly connected to the thing here, how do we need to refine the engineer role here? So what does the engineer actually do in this world? Human interact with the system almost entirely through prompts. And an engineer describes a task, runs the agent and allows it to open a pull request, right? So to drive API to completion, engineer instructs agent to review its own changes locally. So request additional agent reviews both locally and in the cloud, respond to feedback, iterate in the loop until all agent reviewers are satisfied. Okay. So human may review pull requests, okay, but they are not required to do. What humans should do is to give the proper information to the agent. So that at the end of the day, over time, almost all review effort has been pushed toward being handled agent to agent. Okay. So the human, well, they always in the loop. But the most important thing is that human work at the very fundamental different layer of the abstractions, what to project work, what to delegate, and the rest of the writing of the code should be delegated to the agents. So what I want to say in a radical manner is don't write any pieces of code. Even you don't need to read a code. So what the human needs to do is to try to look at every single test, write a test about it, and then make sure each test is based on the story. To write the test based on its own scenarios that is directly connected to our daily world scenarios. So write a scenario test that is directly verified by the humans, and the rest of the layers are being abstracted by the agents. Okay. So let's talk about agent mental model. What I want to say here is that how do we need to think about agent decoding these days? So basically this equation, like this mental model, has been derived by the Gabriel Cha from the OpenAI Codex. So like, since this is a closed code meetup, I just want to explain it in a closed code context, okay? So let's say this. Model plus harness from the plus services. That is how we define agent, okay? Agent is composed of model, harness, and surface. So, what is model? So basically what the model is like, model is like Opus 4.6. Yeah, that's a model. Okay. So, that's the thing, like model, so like our assumption should be model is already excel at its work. Okay. So basically model provides intelligence. Okay. So, but like at the core of the Claude code, like, or other coding CM agent, like those models are optimized specifically for a software engineering. So at a basic level, like LLM press the next grade, and the code is a text basically. But the reasoning variant like go beyond like autocomplete, right? So before producing an answer, the model can perform structured internal reasoning, like for example, like decomposing the task, evaluating options, and planning multi-step edits, right? So those actions are being executed by the intelligence. But as I said, those actions, who runs the action? Who decides to run the action? Yeah, that's the model, right? Model decides what to do. Like intelligence decides what is the next step of the action. However, the most important thing is harness. Why do we need harness? Well, real software engineering is not just of like generating lines of code. Like it involves like very bit of things. Like let's talk about like it's like editing across many files, responding to failures, right? Or running tools, decide what skills to execute, right? Or iterating until something actually works. So basically, like intelligence itself, it knows what to do, but the basically executing model is just a mere inference. Like we request model with a simple prompt, and the model gives output. Okay. So basically, like model is a playground. Like think about like model is just intelligence into your brain, but the brain does not have its body. It does not have the leg. It does not have like hands, right? So basically, model needs the playground where the intelligence can execute its action. Okay. So that's the reason why we need a harness. Harness is the most important thing because it turns a model into an agent. Okay. As I said, like model can generate the code. It can suggest edits and reason about a diff. But what it cannot do is like, but it cannot do in its own. It's like it does not operate in its real repository. Like someone needs to give a appropriate prompt. Like for example, when you like interact with the model in a chat interface, like we did in the very pre-Claude code era, human copy and paste is relevant code. However, like if you use Claude code, you never copy and paste the raw code, right? Why? Because like harness help model to retrieve the relevant code. For example, like if you have some trouble in specific React component, like model requests a certain component name, and the harness like try to find it, or at least like if the model tries to find something very ambiguous code, then harness try to retrieve based on like relevant context and try to inject it, right? Or if it is really not explicit at all, then harness can help model to run in a very like some, for example, 3 parallel environments at once, so that it can like try to experiment till some conclusion has been made. Okay. So what I want to say is that harness gives a playground. Harness gives some kind of some actions to model to do something actually works. So let's say harness is the system that connects the model to a working software environment. Okay, it provides an access to files. It provides some access to repositories, and it gives the ability to run commands like shell commands safely. Like sometimes it requests like some like pseudo permission, right? Or sometimes like you can just run like just adding a dangerously skip permissions, right? And there is some structured way to pass information into and out of the model so it can take on large tasks without collapsing under the context, okay? So, what I want to say is that harness engineering is the most significantly important these days. And I would believe that harness would be very different against each different scenarios. So like if you only work in front end, then you can just like craft your own harness on your specific front end task. But like let's say if you are working as a full stack engineer, which is very common these days, then you need to set up like how you give a proper way to inject context for the model. For example, if you set a monorepo, then your harness should be crafted as your monorepo is being well adjusted to your structure, right? So let's say it's not a something for full stack, but it's all about let's say, for example, if you are trying to craft like some let's say some core engineering of the blockchain, then you need to set a very strict harness for the Rust engineering, right? So those harness are very different to each task that you are going to want to work with. So I think like this is the new responsibility for engineers to give a proper playground for the model, so that we can just extract the best intelligence from the model itself. So let's just summarize, like harness itself is the system that connects the model to a working software environment. So like it provides a controlled access to files, right? So it just lets the model to put an extra context and then use the tools to get work done, right? So let's say like MCP servers, skills, and how do we help models to code those how can I say, those like supplementary materials right time, right about in a time, right in runtime. That's the most important thing, and that is one of the most important like responsibility for harness to do so. So like just give a supplementary actions to the model, okay? So without the harness, you have some suggestions, but if you have some harnesses, then you have the executions, okay? So basically you can just think model and harness, they are interconnected. Why? Because basically Claude code model, like Claude models itself, are trained in the presence of the harness. What I want to say is that, well, you can look at every single model's evolution. They are trained by the environment provided by harness. So what I want to say is that harness itself gives appropriate environment for the model to train on the potential cases of writing a code, right? So tool use, like execution loops or compaction or iterative verification, they are not bolted on behaviors. Like they are a part of how the model learns to operate. So the harness, like in turn, is shaped around the model's plans and invokes plans and recovers from failure, okay? So like a professional trains with a specific equipment for years. So model is a professional athlete, and the harness itself, like their racket, like there's some equipment, right? So you would not swap it out of the day before the competition, right? And expect the same, like expectable performance. So like each like Claude's behavior emerges from the pairing. Like change one, you need to change the agent. Okay. So the basically, you can just think that model itself uses harness and basically like how as a result of the inference step, the model itself produces a final response to the user's output, request of tool code that the agent is expected to perform, and the agent executes the tool code and appends its output to the original prompt. And like the output is used to generate new input that is used to recreate the model. So the agent can take on this new information into account and try again, right? So this process repeats until model stops emitting tool codes and instead produces a message for the user message in the models, right? So this means that as your conversation grows, so does the length of the prompt used to sample the model. So the length matters because like every model has a context window, right? Which is the maximum number of the tokens that you can use for the one inference call, right? So, as you might imagine, like the agent could decide to make hundreds of the tool calls in a single turn and potentially exhausting the context windows. So the context window management is one of the most important, like harness, the responsibilities. And even like model uses harness to like evaluate how many like tokens are being remained. And then try to look and then we just try to truncate automatically, and the harness gives its trigger to the model to compact its context, and the harness saves the relevance of the part of the context so that the harness can inject in a rule-based manner to the model's the prompt to make sure it can continue until certain part of the work is being done. Okay. So as you might have heard about Ralph, so basically Ralph is like trying to run specific execution until your task is being done. So it's basically like, it's effectively like a while loop. So like harness helps the model to run in a Ralph mode because like, harness itself, is, basically, deterministic. So that the deterministic logic helps the model to run in deterministic stuff. So what I want to say is that like harness have a while loop. Like just simply say harness is a while loop, like run a model with a 10 times. And this is also like harness responsibility to inject the right amount of instructions, right context into a model as the Ralph count goes up. But at least let's say, okay, we can run a model to, for example, only just like 10 times or like till the certain criteria has been passed, like passing all the tests. So that basically the harness gives a Ralph mode to the model so that it just try to use the model. Okay. Yeah. So that's the relationship between model and harnesses. So that is the last thing. That's just surface, okay? Surface is the last thing. So once you have model and harness, you have an agent basically, okay? The remaining question is like how you want to use it. So this is the product surface. So if you have tried to use OpenClaw or PyModel, that is how you shape those agents, which is product plus harness. So surface, like why OpenClaw got traction in the first place? OpenClaw gives, for example, like first of all, like OpenClaw gives pseudo permission of your computer, your local computer to the harness. And then model can excel at like managing your computer because like basically harness gives computer harness lets the model to use each computer. Because like harness has a pseudo permission, right? So that's an OpenClaw harness. It's very simple. Just like you can just rebuild your OpenClaw from the scratch, and there's a tons of the repository that I will talk about later. And basically, there's on other things like Surface, as I mentioned, like OpenClaw lets you to connect to Discord and Slack or whatever, or Telegram, whatever that. And it gives a very simple way to health check between the messaging platform and OpenClaw, so that you can take all of the advantages to the user message platform. Yeah, there's some experiment with the Slack, with the Discord previously, but like OpenClaw makes it like abstraction layer to have connections to the messaging platform. So like it went to very viral, right? But at least like this is a very simple, like give us the permission to harness, and then make sure that harness give a right amount of prompt and right information of the context to the specific prompt when you're doing something on the action by the model, and you give a surface to the those agents. So that's a basically OpenClaw, and then you can rebuild from the scratch as well. Okay. So anyway, like you can use Claude code in different ways. Like for example, there is voice mode. There's a remote control mode in these days, and it depends on your task. You can run those agents, and you can give a specific comment in a different way. And if you have chances to use ask your question skills, given which means that teacher takes an interview with the agent before conducting certain actions, like which is very, very helpful. And then it is kind of a combination between surface and harness, right? Harness gives us like deterministic skills to run, ask your question skills, like doing a user interface skills before conducting specific actions. And when it comes to first surface, like it gives a proper way to communicate with the user. So the ask your question skill by the Claude is one of the best example to combine harness and surface. Okay. So like, sometimes you want to supervise multiple long-running threads in parallel, right? So like you might have heard lots of ways to use multiple Claude sessions at once using like splitting the panels on the Claude on the Claude code. That's what I will try to demo in a later way. But how do you manage those multiple sessions at once? Like our cognitive limit, even for gives limit the problematic, because like, well, there's a multiple session that we can respond, but our cognitive like limit does not like follows on those number of tasks that we need to manage at the first place. So like how do we manage that is a problem. That's the surface issue. Okay, and sometimes you want terminal native composability. That's a surface issue. And sometimes you want to have a lightweight entry point for remote asynchronous work, as I mentioned, like voice mode or remote control mode. Yeah, so the Claude code exists across multiple services. Yeah, because the different stage of the software development life cycle demand different interaction patterns. Okay. Yeah, so basically under the hood, Claude code works like in the agent SDK, and it's very difficult to like look the very like exact how the harness it has, because the Claude code is not open source, but at least like you can just assume it, and then you can just build your own plugins. Okay. So let's get back to it. I just want to talk about how the full autonomy it works in for the agent. So basically, the reason why I have spent my time to explain the mental model for 25 minutes and to explain those full autonomy is that those mental model is very worthwhile. Like, there's a tons of folks talking about OpenClaw, NanoClaw, Claude Code, Codex, or OpenClaw, or my OpenCode, blah, blah, blah. But they are really the same. He just tried to automate the work. Okay. So like, it runs those like same stages at the end of the day. validate the code base state, tries to reproduce something symptoms based on the user's prompt. For example, there's a bug, and try to like record the failure issues. Like for example, if you have some connections to the MCPs to Playwright server, then you can record the failure video of the front end. Then you can just give directly those like photos or screenshots or whatever to the model, right? And try to come out with the plans, implement the fix, and validate the runtime, and record the resolution or capture the screenshot, and open the pull request, and try to trigger other models to give a feedback, and remake it by build failures, until it goes the full autonomy, okay? And it's a whole like full cycle. So basically, when you encounter any agent systems, just give it 3 questions. First of all, what model is it trying to use, and how the model intelligence is being channeled. The second is like, what does the harness look like? What tools? What session management? What context engineering? What enforce mechanisms? It's like, for example, the hooks. I think like hook is the most important one in the harness, because like as there is a more deterministic way that we use in LLM, the rule-based one is very important to look at. Okay, so let me give an example. Okay, so here, I just want to introduce patch, replace, and hash line. What is this? What the heck is this? So basically, those are the hooks. Those are the tools that has been used by harness. Like if, let's say, your model determines to edit a certain part of the line, for example, then what it's going to do is try to find the specific lines that has been suggested by the model, and the harness is try to edit. Like for example, the model tries to edit the 15 line and 16 line and 18 line of the code, right? Then it just tried to edit by the harness. Okay. Like Claude Code tries to inference which line to edit. Then the CLI tool, code edit tool, then it actually modifies it. So, well, that's a patch. And what is replace? Replace means like if your model decides to replace with a keyword called for example like function, the keyword function, then the harness runs the replace tools to find all of the lines that includes function. Then it tries to edit its name to something else, right? But let's say those models and those harnesses are trained concurrently. So the model has their own tools, own playground, own harness that has been trained to work in that way. Okay? But the things to note is that if we change the model and the harness combination, it won't work. So let's say the patch, this is the hook, this is the code editing stuff that has been provided by the OpenAI codex, and replace, that is from the Claude code. Okay. So let's say Gemini 3, which is a Google model, to use patch skills, to use replace hook, then it does not work in that way, right? Yeah. So it's a patch hook, replace hook, right? So, how can we use multi-model? So for example, if you want to extract every different models, the best intelligence, so that you can run such a kind of council for each models, so that let's say your harness is being designed to get a code review from all of the best knowledge, best state of the art models like Gemini 3, Claude Opus 4.6, and GPT 5.4 codecs. Then you should use very basic hooks, but works pretty well for all of the models, right? Then how can we make it use of it? So that is the one of the consideration as a harness engineer should do. And when it comes for like code editing, this guy suggests a new way to edit it. It's like hashline. What is hashline? It's very simple idea. Just before executing certain lines action, you need to verify whether those lines are being changed or not. There is a hash line, there's a hashed identifier for each line. And before models to conduct each inference, you can leave your own hash identifier each line. So that's a basic procedure. That's a rule-based procedure. Like before running or added a model, you can just like get out each like hashed identifier from each line. And after the inference of the model, before just simply executing those actions, you can just compare whether those lines are being changed by other sessions, by linters or whatever, by humans humans. Then you can just simply verify it. And if those hashed identifier of specific lines are being changed or not matched at the first place, then you can rerun the model to conduct a certain action, right? No, like trying to suggest new ways of doing that. So as you can see on the format benchmark, hashrun is very neutral hook to edit the code. And it pretty runs every single model very well. Like, let's look at just like GNM 4.7, which is Chinese open source model. Then you can look at the it improves by 23% point for the success ratio of editing the right part of the code, right? And then you can look at every single model has the similar tendencies to do it. Okay. So that is one of the raw example to give a light why we need to look at the combination of model and harness. Okay. So the perspective of learning how those model and harness has its the best fit on the combination, I just recommend you to look at some open source as I told earlier. So I'm just trying to look at every single best of the open source in these days because they have tried to experiment on the multiple models and the multiple harness at the same time. So I want to examine briefly is PyMono. Okay. So when it comes for PyMono, I chose to start here because it is a clear example of the model plus harness plus surface architecture implemented as a working one. It's a working mono repo. So it's not a kind of SDK, but it's harness centric mono. Okay. So it accepts multiple external LLMs, normalize them into a common agent runtimes and projects to runtime across terminal, web, Slack, infrastructure services. So those philosophy is applied to every single other coding AI agent like Claude Code, Codex, and whatever it takes. And I think it's very important to understand the harness engineering these days because you can adjust your own harness or you can just add up the new harness on top of the Claude Code, for example. Unless you need to have those writing a coding set agent from scratch, but it's most important thing. I think it's very important to understand how it works so that you can just adjust its harness to your needs. Okay, so high level structure of this PyMono looks very simple. Let's go to packages. There's some AI, there's agent, there's a coding agent, and when you look at the coding agent, there's some CLI, core models, and TYs. Okay, so I think the most important thing is like one of the most important things is like AI. So let's just start at bottom. AI is where the pi minimum is the external model world. So the design center of this package is not a provide names, but it's like API contract, okay? So what the matter is not like, is this like Anthropic, Haiku, Anthropic Opus or OpenAI Codex, but what API surface does this model follow? And how do I normalize its output into a format the rest of the system can consume? Okay. So the core of this normalization is captured in a remarkably concise function in stream.typescript. So this looks very simple, but it encodes its entire philosophy, I believe. The model object carries a model that API failed. A registry maps the API identifier to a correct provider adapter. And return type itself is not a string completion object, but it's like message event stream, right? So that's a model type. So that's a model layer, as I told you earlier. And there is some agent one, which is the execution loop. Okay. So moving up the stack. Okay. This package is where the normalized model output becomes actual execution. So this is generate agent loop, like core feedback cycle that turns model suggestion into a real world action. Okay. So, when you look the file header of this, it states very like design philosophy explicitly. So this is a crucial architecture decision, I believe. So the internal representation is an agent model, like there's a native type that is optimized for session storage, UI rendering, steering retries, and the follow-up logic, okay? So the conversion of those provider-specific masters format happens only at the very last moment. So right before the actual API call. So this means that entire runtime operates in its own languages. So insulated from the vagaries of the different provider APIs, okay? So, so the basically like agent, receives a response from the model and it inspects the response, for two calls. And if the two calls exist, it executes them, collects results, and feeds those results back into the context for the next iteration. So those continues until the model produces a response with a no further two calls or until some termination condition is met. For example, we do run rough mode for only 20 times. Okay. So like this loop does not just like blindly execute two calls. Like it just try to validate the argument and perform repair when there is a malformed. Okay. And also like it handles the continuation problem, like when a model hits its output and token limit mid-response, like the agent loop detects this and issues a continue prompt to resume the generation. So this is like one of the small details, but it's essential for long-running tasks, and where a single term might involve extensive reasoning and multiple tool calls. So you can see like those are harness, and those harness are deterministic logic. Okay. So this is not a simple response wrapper. Like it's like resilience execution control that manages the full life cycle of an agent turn. Like failure modes that only emerges in the production use. Okay. So, let's go to coding agent. What is coding agent? This is a composition root. Okay. So, this is where everything comes together. So, AI is a model layer. Agent is an execution loop. Then the coding agent itself, like full product harnesses. So the composition loop that assembles an actual usable agent systems. Okay. So, basically you can just look at the, SRC main TypeScript, that rebuilds the two-stage CLI parsing. Like what I say two-stage is, here. It's like the system like first parses arguments to discover which extension should be loaded, and it then loads those like extensions like which can register new providers, new CLI flags, new comments, or new tools. Okay. Then it parses the arguments again, and at this time understand the flags that extension added. Okay. So like CLI is just like just a fixed set of the switch. Like it's a runtime configurable interface, as I per se. So the capabilities of like agent system like change depending on the what extension are installed. And like this is like a Pi mono feels more like a platform than a tool. Like extension does not just like add the new prompt, they add capabilities to the runtime itself. Okay. So that is the extension harness at work. So, and it's the reason this two-stage parse exists, and the system literally cannot know its own capabilities until after extension have loaded. Okay. And there is some agent sessions. So let's go to the core and agent sessions. It is arguably the most important single class in the entire Moon repo. So like it handles like agent state access, event subscriptions, and compaction, the bash execution, and the hook calling, for example. So like when a user types a prompt, it does not go straight to the model, right? It passes through the agent session, which evaluates like, first of all, this is a slash command. It is a skill block. Does it need to template extension? Is this the current model ready? Or has the context grown too large? Does auto compaction need to trigger? Should an extension hook intercede? So it's not just a prompt folder, like it's a session level execution hub, so that the thing that maintains the state, enforces policies, and coordinates the flow of the information between the user, the model, and the tools and script layer. Okay. So you can just look at those ones like Pi Mono, so that you have some understanding how those harness being worked with the model. So like you can just add it some specific codes to do a match to your own harness. So I think it's very important. Okay. And last but not least, there is a web UI here. So basically it gives surfaces like TUI, web, select, pause. Okay. So like it implements like retained model UI runtime. Like if you look at the Claude code, like it's basically written in a TUI. So like it gives the surface how you've been connected. So let's say if you want to add new voice mode for your Claude code example, then you can just work with the surface layer, which is a Pi web UI in this case, right? Okay. So let's do some demo in this time. So the first demo is on my Claude code. So my friend built this. So like it's a kind of system architecture that extends the Claude code into a multi-agent execution platform, right? So the OMC's strength is to make sure that Claude code to run its own TMUX panel, it run its own multiple terminal panels, so that it can run a different team mode or different models at the same time. Okay. So basically, let's just jump into the on my Claude code. Okay. Oops. So here it is. Let's go for OMC. Okay. I have already installed on my Claude code. Yeah, on my Claude code. So I try to use it. Okay. So there's some comments for run it like OMC team. So let's spawn 3 teams. Find any security issue. Then what it's just going to do is to make sure that it runs on multiple personas, multiple models at once, like Gemini, Codex, Claude. So that basically it runs the multiple panels behind of it. So basically, like you can just look at it creates a team of 3 agents to audit the code base for security issues, right? So it runs terminal behind it. It tries to spawn multiple Claude sessions, so that like there is an orchestrator, and the orchestrator manages the multiple sessions, multiple TMUX panels, so that orchestrator gives a clear command to the agent. So you can look at the multiple panels being assigned, and those orchestrator and those agents are being communicated in the inbox pattern. I think like inbox pattern is also being used by Claude Code Swarm mode, which has been released 2 weeks ago. So basically, it's like this. Orchestrator gives a clear commands to the agent, and then those agents are being communicated with the markdown file. And now there's instructions in the markdown file, and every 5 seconds, like agent reads these instruction box inbox. There's an inbox. There's a folder. There's a directory. Each agent reads the instruction messages, and if there's a new messages, then it tries to run it. Or if there's a multiple messages, that there is a queue to getting it being managed. Okay. So what OMC does is to build on top of like swarm mode. So like it just try to like spawn multiple TMOS panels and to make sure that each agent maintains each clear context so that it can reduce the inference time. It can improve the accuracy at the first place. Okay. So there's a security audit task, security audit request, security audit test as well. And each agent are being assigned with a different task, and each agent can have each different order. So for example, there's an agent A, there's an agent B, there's agent C. Then agent A has the dependencies to agent B, and agent B can have a dependency to agent C. And how those being managed is like being determined by the orchestrator. And then you can have a set of the workflows of it, and orchestrator can call relevant predetermined workflow seamlessly. So that's how all my Claude code works behind it. Yeah, I'm just running out of time. So this is one of the demo that I just try to look at it. And yeah, basically like this plugins is run on top of the your Claude code plans. So I just recommend you to give a demo for yourself. Okay. Yeah, that's how it works. Okay. So yeah, that's how it works in the first place. And this is the another example that I want to show briefly about the demo is our Ouroboros. So conceptually the most ambitious of the systems I've analyzed is like this Ouroboros is a specification first agent orchestration platform. Like it refuses to let agents to start working until the problem is properly defined. Okay. It just trying to constrain all executions against that definition and continuously evaluates whether the agent is being drifting from the specification. So like, it introduces users to structured and ambiguous requirements and locks them into an immutable specification and orchestrates the agent execution against that specification and evaluates results through a multi-tier pipeline and evolves specifications through generation refinement. So like, let's do some quick demo. Okay. So the most important thing here is like the harness itself, it gives the plugins of the harness is try to add the abstraction layer that asks the users to conduct the interview till every single points are not ambiguous, and then executes those plans. Okay, so it's like a advanced plan mode, I would say, and then you can create your own plan mode. You can create your own, ask your questions or custom to your prompt. Okay, so let's go to that part. So I just like add the OOO. So there's a Socratic interview. Okay, so when the user starts Ouroboros, like they don't get a prompt, they get an interview. The system asks the questions to surface hidden assumptions. It quantifies ambiguity, later exploring how unclear the requirements are. Like this is deterministic law, and it does not proceed to execution until the ambiguity score drops below its threshold. So let's say web browser. So I just asked about a Pac-Man game. Also user, Facebook, working with production, just okay. So based on that, it gives a constitutional center, which calls seed out of Ouroboros, and every other component in the system refers back to it. Okay. So basically, there is some orchestrator in the runtime center of Ouroboros, and it takes a seed and transform into executor work. You can look at the amount of the ambiguity score. So basically, if those the ambiguity score has been lowered with a specific criteria score, then it says that it is like okay to execute the plan, right? So that's an honest assessment of maturity of your plan. So like basically it tries to make sure that you write the like correct requirements, you have correct communication with your agent so that it improves the chance of getting things done. Okay. So you can think like this is like advanced user ask mode. Okay. Last but not least, I just want to wrap up today's presentation to introduce OpenGateway. So like OpenGateway is like my startup Sionic AI tries to push like multi-model provider. You can think of this like open router, right? So the most important thing here is that it is very well suited into the multi-harness engineering, so that you can just clearly look at what kinds of models being supported and what kinds of harness being traced, and it's pretty resilient on the failure of the multi-providers, and then you can just clearly look at what happens under the hood. So yeah, we are trying to launch this product because we have the lots of experience on adjusting specific harness behaviors into models. So that I think like OpenGateway provided by Sionic AI is well suited into your product development. So we're trying to do some like events for those who are meetup participants. So I just want to give a $20 credit gift to the participants of today's meetup. So like please sign up here, and then after that just give me your like email address so that it would be nice to kind of get some of the credit for you. Okay. So I will post the domains for you, the OpenGateway sign.im. I will just like let Daniel to have those link on and the other open source link that I have demo today. Okay. So after this meetup, I will give you a form to type in the email address, and then you can claim your like credits. Okay. So thanks for the invitation today. And it'll be better to see you in the IRM mode. And I think I will be down on the network school on the April. So let's see you up there. Thank you very much.